This video is on Fukushima. It's a follow-up to the earlier video I did on Fukushima, and I've got some more information to share and some ideas. Just as a recap, this is the original slides I was using. Just as a recap, there was a explosion at 3 of the 4 nuclear plants in Japan, Fukushima Daiichi, north of Tokyo in Japan in 2011. There were 4 plants affected. There are 6 plants on the facility, 2 more that we've not heard anything about in years. I don't know what the status of those two are. But the other 4 have been completely destroyed. On the control rods and everything are destroyed, and the plants are completely out of control, and they're submerged in water, seawater, and they've been leaking into the sea and causing problems since 2011. So this is an update on the latest information we have, March of 2017. This is the area of Japan, the main island, and you can see Tokyo down here. It's mostly this white area. It's a large metropolitan area, several million people. Fukushima is north of there, about 120 kilometers, maybe 90 miles north, and it's close to right on the water because of the cooling of the ocean. They use the water for that. So there are also 45 plants, nuclear power plants in Japan, that are shut down, that the people do not want restarted, and the government is regularly trying to restart. So it's a really big problem in Japan, has been for a number of years. Now, some people have said the things that I've noticed, the heat and the water around Japan, are caused from volcanoes. And there has been a really big volcanic eruption east of Japan here. It created an island out of the ocean. That's what happens when these volcanoes start from the bottom. They build up and build up mountains until they finally go through the top of the ocean, create an island. It's very common. And so recently, in the last 6 months, one of these has popped up. But the problem is, first of all, this is quite far away from Japan. This is far east of Japan, and would not account for the heat signature that we find in northern Japan. And there's some other things. But I said, possibly these things are being caused by volcanoes. So I need to investigate this more and see what I can find about the volcanoes. Now, I know this map is hard to read because it's blown up of a small map, but you can see there is a red line here indicating the area of volcanoes. Now, Japan sits on the corner of 4 plates, so there's a lot of seismic activity here, but the volcanoes pretty much are along this line, and of course most of them are on the land. That's how these islands probably originated, was from volcanoes, and they continue further down here underwater, and so we'll take a look at that. Now, these volcanoes are well known. This is a Smithsonian data that is interconnected with Google Earth so that you can see them here. And I'm just going to show you the area in the ocean because that's what we're concerned about here. And islands that, volcanoes that don't come up above the ocean surface are called submarine volcanoes. So there are several of those that are categorized here in the Smithsonian data, and they're along this line south of Japan through the Mariana Islands, and it's quite a famous area. And I've got one right here, and I could zoom in on it. We could see it in more detail. So it's Smithsonian Institution is providing all this data, and they're considered the most accurate for volcanic activity. There is a volcano discovery website, but Smithsonian is considered more accurate. And the problem I have is, using the Smithsonian data, there is no volcanoes near the area in which we have these large heat signatures. So that causes some difficulty with my understanding. This is a marine geology map. It's like a topo map in reverse. It shows the underwater features. And here east of Japan we have the Japan Trench, and if you follow this down it becomes the Mariana Trench, very famous, probably the deepest place in the world. And you follow it down some more, it goes to Philippine Trench, and those are really, really deep places. This area here in the trench is about 7,000 meters deep. That's 21,000 feet, and in here it's about 5,000 meters deep, 15,000 feet. So this is a deep area south of the northern island of Japan. This is the tip of that northern island of Japan, and these are the deep regions. And typically we don't see volcanoes in a deep region. They're in the higher regions or along a line. Now there are 3 or 4 here seamounts, which are sea mountains. These are things that come up from the bottom, but they're not very high, and they're not active, and they're not listed in any of the seismic activity for active volcanoes. So it's unlikely that these here are making the heat. So because our heat signature is the biggest one, hottest one is right in this area here. So we have to wonder what's causing this. Now here's another problem. Using this tool, nullschool.net, we're looking and we're seeing here the heat signatures with I've got it set for sea temperature anomaly. So these are areas that are above normal, and you can see up in here these are the 2 areas that are most concerned with the sea temperature anomaly. And the white is the hottest region, red is hot, blue is cold. So the blue is below normal and the reds are higher. But out here where that one big volcano that came up out of the sea, we don't see a big heat signature. You know, it might be a little bit above normal, but that's all. There's no area that around there that is identified with a big heat signature. This is the island of Hawaii in the Big Island, and there's a famous volcano here on the south side that's spewing lava into the ocean now for, I think it's been about a month. It's been just a river of lava going into the ocean, and we see there's no heat signature. There's no area that is above normal using this null school tool. And the reason for that is because the ocean is very big, and yes, that lava is hot, but when it hits that water, it cools down very fast and turns into rock. That's why at that location there's so much steam coming out, because the lava is being cooled very quickly. So we have 2 instances of volcanoes in which they don't seem to be having much effect on the ocean water. They're not making a lot of heat in the ocean water. So the idea that these heat signatures we're seeing are from volcanoes doesn't seem to fit. So I have to go back. Is this null school tool that we're using really accurate? And what it says here is the ocean surface temperature anomalies are from an average. They get the average temperature from 1981 to 2011, which would have been before Fukushima, and it's updated daily. And they're using supercomputers to calculate a lot of these things. So it seems to me that if they have all this interconnection and they have all this big data, that this is probably pretty accurate. But we have this problem with this large amount of heat. Okay, now if we take a look here, this is null school as of March 2017, and we see the southern island of Japan, northern island of Japan, this large area of heat. Now down here is Tokyo, up here is Fukushima, and just above Fukushima we find this large section of heat coming out of here, and this is a persistent system. This is something we've seen over a period of months. If it was a volcano, volcanoes don't last that long. They are up for a week or 2 weeks normally, and then they're over with. This has been going on for over a month, and it's persistent, continuous heat signature above normal, and the temperatures are quite high. In this region here, we're at 13.7 degrees Celsius above normal. That's 24 degrees Fahrenheit above normal, and that's quite a bit. Now, typically they're between 9 and 15 degrees above normal, and if I here is the actual the same null school, but I've got it set differently. This is the air temperature at that same place, and the air temperature is 1 degree Celsius, or 33, almost freezing. All right, so the air temperature here is almost freezing, but the water temperature is much warmer. This is, I've got this set for the ocean temperature, and it's 19.2 degrees Celsius when the air is freezing, and that comes out to 66 degrees Fahrenheit when the air going past it is freezing. So, and this is a large area that's staying warm, and I've tracked this. Sometimes it goes up to 80 degrees Fahrenheit. It's really, and still the air is almost freezing and going over it. So something here, in my opinion, something is causing a heat signature, or the conclusion I've come to, there must be something that's creating heat in this area of the ocean, and it can't be the volcanoes, because the volcanoes don't fit this pattern, and there are no active volcanoes in this deep region. But we are pretty close to Fukushima, so a reasonable person would come to the conclusion that Fukushima and the problems that we've experienced there are actually warming the ocean. That's the. I hope I'm wrong about that. I'll leave the comments open. Maybe other people have different ideas. I'd sure like to hear it. This is from 2014, The Guardian reporting about the pumping in Fukushima. Tokyo Electric said it released 560 tons of groundwater pumped from 12 wells located from the damaged reactors. The buildup of toxic water almost 2 years after the ministry said that 300 tons of contaminated groundwater from Fukushima was seeping into the ocean every day. 300 tons of contaminated water going into the ocean every day. It's difficult to imagine that much water going into the ocean, contaminated water. And this has been the focus of our concern all along, is this contamination and how the ocean currents might take it up towards North America. And from the original accident of the explosions, there was evidence that some of the airborne particulate went to North America because the wind stream seems to go in a big clockwise direction. So our focus has been on the contaminated water going into the ocean. But I believe at this point the problem is worse than that, much worse than that. We have all this water, and below the recording here it says there are 1,000 tanks on the site. So they're pumping water into the ocean now. And who knows how long they've been doing that, because they haven't been telling us the truth from the beginning. But what they are telling us, it's hundreds of tons of water being pumped into the ocean. Okay, so my point is this: perhaps it's more than just water. Okay, this is the fuel pellets used in nuclear reactors. They're very small. They contain normally uranium 235, and they go inside this rod. They're all stacked up. You can see them here, and there is a sheath that goes over the outside, cadmium, I believe, and that will prevent them from interacting with each other. What happens is a nuclear power plant is a controlled chemical fire. when these sheaths are raised up and these control rods are exposed to each other, they will interact and generate heat in the range of 2,000 to 3,000 degrees centigrade. And so the nuclear reactor is in fact a chemical fire, a very carefully controlled chemical fire that makes hot water, super hot water, that's then sent through a series of systems to drive a steam-driven pump, steam-driven generator. So it makes this super hot water from these interaction of these pellets in the fuel rods. Now, each control room has, each nuclear vessel has some of these, but in all four of these plants, and, these rods are damaged or could be completely gone at this point. This is a drawing I have from one of the websites talking about the pumping going on at Fukushima. I don't know if it's accurate, but typically a pump will have an impeller, either a remote one like this where it's got a long shaft and it's pumping down below, or the impeller will be right up here and it's sucking the fluid up and pumping it out. Either way, a typical house pump would have a impeller right here next to the motor. But either way, it's causing a suction action and it's moving it up. And those pellets could easily be going through these impellers and being crushed into even finer material and being pumped out into the ocean, or some of them could be pumped out on their own. This is the production of raw uranium-235, and this comes out of the ground like this, and it's in a slurry, and then they take it and they enrich it and make it stronger. But it's kind of weak here, and that's why the workers don't have any protective clothing on. They're not too worried about it. The half-life for uranium-235 is 700 million years. So this stuff lasts for a long time. Now, the problem we have is in these four reactors, we have the fuel for the reactors, and then we have what's called the spent fuel pond, or spent fuel pool, which is a misnomer. It's not spent fuel. It's because this stuff lasts for hundreds of millions of years. It's fuel that is not stable. So they have this uranium-235 down in the reactor, and when it starts, after a number of years, when it starts becoming unstable, they take out the control rods and they put it in the spent fuel pool filled with boron, and so it stops interacting with each other. The boron stops the interaction. So it's not spent fuel. It's just unstable. And now we in our damage we have 4 reactor cores that are completely damaged, out of control, and we have 4 spent fuel pools that probably hold, they estimate, between 4 and 5 times as much fuel as the cores. So we have an enormous amount of fuel that's not accounted for, that's that's probably underwater. All right, now what happens is, come back to this. What happens is they take the uranium and they 235 and they start to enrich it. For nuclear power plants, they enrich it to 3 to 4%. That's all that's needed, and then it goes. It's pretty hot at that point, and it goes inside the reactor vessel, and it does its job in the form of pellets. Okay. Now, plutonium, on the other hand, is much hotter. Weapons-grade plutonium is very hot up here, and it has a much higher percentage. Now, for some unknown reason, no one has explained this to me, and I haven't heard people question about it. The Japanese government and TEPCO have said within days of these explosions that these plants contain both uranium-235 and plutonium. Now, these plants were not designed for plutonium. These are boiling water reactors, and you put plutonium in a breeder reactor because it's much more difficult to control. And so why they had a mixture of plutonium and uranium is a big mystery to me, and no one has questioned that or answered that or talked about that. But the problem is we have a disaster site that has a mixture of 2 of these pellets. Now I don't know what the mixture ratio is, but it doesn't matter. The plutonium is a very serious complication in this problem. These pellets interact with each other and create heat, except for the plutonium. They don't even need to interact with other pellets. On their own, they can generate heat. Just 1 gram, 1 pellet can generate 0.5 watts of thermal power. And this is one of the pellets here, and you can see it's glowing. So, and this plutonium will last, the half-life is 87 years. So 87 years, it's half of its power. So it's a long time. So now we have pellets of uranium, pellets of plutonium, and they're mixed together. Who knows what's going on inside these reactors and spent fuel underwater, and they're being pumped up to the surface into tanks, and sometimes they're being pumped out into the ocean. Who knows how many times they've been pumped. It's likely that some of these pellets have been crushed and they're fine material now, and it's going out into the ocean is my guess, because I can't think of another way to explain these heat signatures. This is a very large area. How could we get heat in such a large area unless we had fuel pellets spread out over hundreds of kilometers that were now interacting with each other and bringing up, increasing the temperature of the water? I don't know how many pellets are in those 4 reactor buildings with the spent fuel. Millions of pellets? There's a lot. And so it's my guess that some of them were pumped out into the ocean. Now, it's possible that some of those might have been taken out and illegally dumped into the ocean. I don't know if that happens in Japan. It does happen in North America over the years. There have been cases of that kind of stuff. So that's another possibility, that illegally someone might have dumped it without the utilities knowing. But more likely it's being pumped, because these are very large pumps and they have a problem. They need to get this water out, and they're pumping in tons of water into the ocean. So it's very likely that with some of those tons comes nuclear material. And this is not that far north of Fukushima, but it's very deep. So if water were to come out here, it wouldn't necessarily drop right to the bottom of the ocean. The current could easily take it further, and it could go higher. Now, if we take a look, this is the null school with the ocean currents, and this is of March of 2017. These currents do change from time to time over a period, but it's, there's a similarity of what they're doing. So if the water came out of Fukushima, we can see the current takes it up to a very hot area, a white area. And if you go up to this area, there's 4 or 5 swirling currents that if something got up there, it could easily get trapped and settle to the bottom. So it would not surprise me if there is a higher concentration of fuel pellets up here and there's a smaller concentration of fuel pellets down here, and that's what's giving us this temperature anomaly recorded on null school. So if my hypothesis is correct, what we have here is a nuclear chain reaction in the Pacific Ocean. We have these fuel pellets that were designed to work inside nuclear reactors now out in an uncontrolled environment in the ocean, interacting with each other, and a very large body of water creating heat and probably creating other things, because that's my next concern. Are they creating the toxins that a nuclear reactor produces? Cesium-137. This one moves quickly because it's highly soluble in water. So that and cesium is extremely poisonous. Strontium-90 is very poisonous, and we don't know, there might be other elements that are being created, because we haven't done this in salt water. There might be other elements in this chemical reaction that are being poison, that's being created as well. So it's a very serious situation where we have the area that is persistently warm over a number of months, indicating that there is a something there generating heat, and it's creating a temperature anomaly that is easily seen on this device. So it's a very large scale, and if it continues the way it's going now, this will cause a problem for much more than Japan. You know, in the other video I talked about how many years ago a container of rubber duckies fell off the ship, and the rubber duckies got in the water, and they floated all around the world, and the scientists followed them, and they determined that all the oceans in the world are connected. So if this nuclear reaction continues, and I don't see how it can be stopped, but if it continues, it will likely spread this poison through all the oceans of the planet. And it's not going to happen quickly, not going to happen over the next 10 or 12 years, but over a period of 40, 50, 60, 80 years, it's likely this poison will spread throughout the planet unless we do something to stop it, unless we do something to curtail it. I mean, it should not come as a surprise to us. The Japanese government has come out and said they don't understand, they need help. Please send scientists to help them get this thing under control. So if the people are not qualified to clean up the disaster, it should not surprise us that the disaster has gotten worse. So, you know, I don't know if they're still pumping into the ocean, but probably it'd be a good idea not to pump any more material into the ocean. But it's a very serious problem. It's I don't think it's going to go away on its own, and if someone else could think of another explanation for these persistent heat signatures over a period of months, day in and day out, I sure would like to hear it. I'd like to be really wrong about this idea, but it appears that we have a serious problem here developed off the northern coast of Japan, and it's from the null school information, it is growing a little bit larger every month. So it appears that the problem is getting worse. So I've included my PayPal ID. If someone feels the information is valuable, they want to contribute, fine, I'll still make videos no matter what. But it's something that is deeply concerning, affects everybody on the planet, and if we can't get it under control, it's not a good thing for the future of the planet. So thank you for watching. I'll keep you updated.